Welcome to my channel. In this video, I am going to discuss a numerical problem on mechanical translational system. So our numerical problem is write the equations of motion in S domain for the system shown in the figure. Determine the transfer function of the system. So this is our given system. So in this system there is a mass m, and at this mass m there is an applied force f of t. Because of this applied force there is displacement x. Okay, so the opposing forces at mass m are force due to the mass itself, force due to B1, and force due to B2. K is not connected to this mass, so we should not consider K at this m. But if you observe here, B2 and K are connected to each other, but there is no mass between these two elements. So when mass is equal to 0 at the meeting point of these two elements, and we will assume some displacement at that meeting point. So how we will assume, we will see in the next slides. So initially, what is our input? F of t, and what is our output? X. So Laplace of f of t is f of s, Laplace of x is x of s. So input is f of s in Laplace, output is x of s in Laplace. So what is the transfer function? Laplace of output by Laplace of input, that is x of s divided by f of s will give us the transfer function. Okay, as I have already told you, at the meeting point of K and B2 there is no mass, so we are assuming mass equal to 0, m equal to 0, and displacement, let us assume at this meeting point of K and B2 is some x1. So we are just assuming m equal to 0, and we are assuming the displacement as x1. Okay, so if x1 is the displacement at the meeting point of K and B2, what is the Laplace of x1? That is x1 of s. Okay, and mass x1 of s is the Laplace of the displacement that we have assumed at the meeting point of K and B2, and mass at the meeting point of K and B2 is what? M. So now actually there was only one mass in the given system, but we have assumed another mass whose value is 0 at the meeting point of K and B2. So total how many masses now? There are two masses. Of course one mass is 0, but we are considering that also here. So there are two masses. So we can say there are two nodes here in the given system. There are two nodes. One node is m, another node is m equal to 0. Okay, one node is m, another node is m equal to 0. So now we can draw two free body diagrams. Okay, we can draw two free body diagrams. So I will just copy this image. Okay, so this is this image I have copied it here so that it will be easy for you to understand. Now this is it. So I am considering mass m now. So I am considering mass m. So this mass m, if you observe, I have drawn mass m here. What is the applied force at mass m? F of t. So this is our f of t. What is the displacement? X. This is x. What are the opposing forces? One force is due to m itself, so Fm. Other force is due to B1, Fb1. Other force is due to B2, that is Fb2. So this is our free body diagram. So let us write down the let us apply Newton's second law and write down the force balance equations in time domain. So what is Fm now? M into d square x by dt square. Fb2 if you observe in the previous slide, Fb2 is in between what? In between x1 and x. Now we are considering m, so we have to consider. Okay, so Fb2 will be equal to what? B2 into d by dt of x minus x1. Fb2 is equal to what? D by dt of b2 into d by dt of x minus x1, because it is in between these two masses. b2 is between m equal to 0 and m. Okay, b2 is between m equal to 0 and 1, so we have to consider both the displacements. Therefore, so fb2 is equal to what? b2 into d by dt of x minus x1. What is fb1? b1 into dx by dt. Okay, fb1 is equal to b1 into dx by dt. So now, by according to Newton's second law, what is it? What is our force balance equation? Fm plus fb1 plus fb2 equal to f of t. So what is Fm? M into d square x by dt square. Fb1 is b1 dx by dt, and fb2 is b2 into d by dt of x minus x1 is equal to what? F of t. So this is our differential equation. Now we can take the Laplace transformation of this equation. Okay, so we can take the Laplace transformation of this equation, and we can write down the Laplace transformation equation for this. So how to write? We will see. So this is it. This is our differential equation. You have to convert that into Laplace form. So dm into d square x by dt square is s square x of s. b1 as it is, you must write, it's the constant. So dx by dt is s into x of s. b2 as it is, you just write d by dt of x minus x1. So s into x1 x of s minus x1 of s equal to f of t is f of s. Okay. So this is our differential equation. This is our Laplace transformation equation. So in this so that's what is there in the next slide. So this is it. So just take here, what you have to do is you take x of s common from these three. You take x of s common. So what is the coefficient of x of s? ms square plus b1s plus b2s. Okay, ms square, b1s plus b2s. Here I have taken s common and I have written b1 plus b2 into s into x of s. Now similarly take x1 of s common. Where is x1? As only one x1 of s is there. So b2s into x1 of s. b2s into x1 of s is equal to f of s. Consider it as equation 1. Okay, now let us draw the free body diagram at the meeting point of spring and dashpot. Okay, so at the meeting point of spring and dashpot, mass equal to 0. What are the opposing forces? Fk and Fb2. And what is the displacement? x1. And we know B2 is connected between both the masses m equal to 0 and m. Therefore, Fb2 is equal to what? B2 into d by dt of x1 minus x, and Fk is equal to k into x1. Okay. So these are the opposing forces. Applied force is not there. So by Newton's second law, so Fb2 plus Fk is equal to 0 because applied force is not there. So what is Fb2? B2 into d by dt of x1 minus x, and Fk is k into x1 equal to 0. Okay. So now what is this is our differential equation, isn't it? This is our differential equation. So what is our Laplace transformation? Applying Laplace transformation, what do you get? So b2 as it is just write it down, b2 d by dt of x1 minus x. So s, only one first order derivative, so s, okay, into x1 of s minus x of s, k into x1, instead of x1 you just write x1 of s. Just substitute here. Now just take x1 of s common and x of s common and rearrange the terms and write the equations. Okay. So when you take x1 of s common, the coefficient of x1 of s is b2s plus k. Okay, when you take x of s common Of course, there is only one x of s term, so b2 of s into x of s is equal to 0 you will get. Now you can rearrange the terms. We have to eliminate x1 of s now. So I want to eliminate x1 of s, so I have written x1 of s in terms of x2 of s. Above equation, you just rearrange the terms, you will get x1 of s is equal to b2 of s by divided by b2s, x1 of s is equal to b2s divided by b2s plus k into x of s. Now substitute this in your equation 1. Substitute x1 of s from equation 2 in equation 1. If you substitute that, you will get, what do you get? M s square plus b1 plus b2s whole multiplied with x of s minus b2s into b2s by b2s plus k into x of s is equal to f of s. Okay, this is it. Now here once again just take x of s and x of s. You just take x of s common, you will get the second equation. So this is it, x of s into this whole term, x of s into ms square plus b1 plus b2 into s into b2s plus k minus b2s whole square whole divided by b2s plus k is equal to f of s. So what is the transfer function? Laplace of output x of s by f of s is equal to b2s plus k by ms square plus b1 plus b2 into s into b2s plus k minus b2s square. So this is our transfer function. Okay, so we have got the transfer function. So what did they ask? They have asked us the equations of motion in S domain. So I have written even differential equations also. They didn't ask this, but I have written the differential equations that we have got earlier, and I have written their corresponding S domain equation, that is Laplace equations. You can write it down if you want in your notes, if you are copying this video, and later, since whatever transfer function that they have asked, which we have already obtained, that transfer function I have written here. This is it. I hope whoever is watching this video, if you want me to make any modifications in this video, you just mention in the comment section. If you are unable to understand at any point in this video, you just mention in the comment section any modifications that you want, any video regarding any topic related to electrical engineering. If you want, you just mention in the comment section. Thank you for watching this video.